welcome to the deep dive. Today we're going to be unraveling a pretty complex topic.
Oh, yeah.
Artificial neural networks, or ANNs.
ANNs.
And we're going to be basing our deep dive on an essay by Jörg-Owe.
All right.
So I guess to kick things off,
Yeah.
when we talk about artificial neural networks, we're essentially talking about the building blocks of AI.
Yeah.
Those systems that can learn and adapt almost like
our brains.
like our own brains.
Exactly.
And that's, I think, what's so fascinating about this topic is that it really gets to the heart of how we can create machines that can think and learn like we do.
Absolutely. And I think what's really exciting is that it's not just a theoretical concept anymore. We're seeing ANNs in action all around us.
Yeah, like where are we seeing this in our everyday life?
I mean, think about it like when you're shopping online and you get those personalized recommendations, or,
Right.
when you unlock your phone with facial recognition, or you're asking your virtual assistant to, set a reminder or something. Those are all powered by ANNs.
Oh, wow.
We're like working behind the scenes, constantly learning.
So they're already kind of integrated into our lives in ways that we might not even realize.
Exactly. It's pretty amazing.
That's pretty mind-blowing.
Yeah.
But I think before we kind of get too far ahead of ourselves,
Right.
let's break it down. Like, what is the basic structure of an ANN?
Okay. So imagine a factory assembly line, where you have raw materials coming in and they go through a series of steps.
Okay.
And then they come out as a finished product.
Right.
That's kind of a good analogy for how an ANN processes data.
Okay.
So you start with the input layer. That's where the raw data comes in.
Right.
Whether it's numbers or images or text. And then that data flows through these hidden layers.
And that's where the magic happens.
That's where the magic happens.
Yeah. What exactly goes on in those hidden layers?
So each hidden layer is made up of these interconnected nodes. It's like a network of mini processors.
Okay.
And these nodes, they're also called artificial neurons. Yeah, they're responsible for processing the data. And they do that through a series of weighted connections.
So like the weight of the connection determines how strong the signal is between those nodes.
Exactly, but like control knobs.
Okay.
They determine the strength of the signal.
So it's like this really complex network of signals being passed back and forth.
Yeah.
And then the weights are kind of influencing how those signals are interpreted.
Yes, exactly. And each neuron, it receives input from the previous layer, processes it,
Okay.
and then passes the result to the next layer. And this keeps happening
Okay.
until the data reaches the output layer, and that's where we see the final result.
So the output layer is where we see like the prediction or the decision that the network's made.
Exactly. The culmination of all the processing that happened in those hidden layers.
Wow.
Yeah.
This whole structure is fascinating.
It is.
But how does an ANN actually learn? Like, how does it get better at what it does?
That's a great question. So the learning process mainly involves adjusting those weights that we talked about.
Right. Through a process called backpropagation.
Backpropagation.
Yeah, it's a bit complicated. But essentially, the network compares its output to the desired output.
Okay.
And then it uses math to adjust the weights so that the error between them is minimized.
So it's like fine-tuning a recipe until you get the perfect flavor.
I like that analogy.
It's constantly kind of experimenting and adjusting.
Exactly. And that's what makes them so powerful. They can learn from tons of data and keep getting better.
Now, you mentioned earlier that there are different types of ANNs.
Yes.
So it's not just a one-size-fits-all kind of thing.
Right.
Can you tell us a little bit more about the different types of ANNs out there?
Of course. So just like our brains have different specialized areas for processing information.
Okay.
ANNs come in different flavors, each one designed for specific tasks.
So what are some of the key players in this neural network family?
All right. So
I'm eager to hear about how they differ.
Yeah. So one of the most common types is the feed-forward neural network.
Okay.
Or FNN.
FNN. It's kind of like the workhorse of the ANN world.
Yeah.
It's used in a lot of different applications.
Okay.
From image recognition to predicting stock prices.
Mm-hmm.
And in FNN's data flows in a single direction from input to output.
Okay, so it's very straightforward.
Yeah.
Like just a straight line?
Straight line, no loops or feedback mechanisms.
So what about tasks that require a more nuanced understanding of sequences, like language translation or something like that?
Yeah, that's where recurrent neural networks come in.
Okay.
Or RNNs for short.
RNNs, okay.
And they have this really cool ability to process sequential data by incorporating a form of memory.
Memory.
Yeah. So they can actually consider previous inputs when making predictions.
Oh, wow.
Which makes them perfect for things like natural language processing, speech recognition, and even predicting time series data.
So like it can understand context,
Exactly.
like how things relate to each other.
Yeah, they're really good at understanding sequences.
That's pretty remarkable.
It is.
Are there any other specialized ANNs that we should be aware of?
Absolutely, for image and video processing.
Okay.
Convolutional neural networks, or
Right.
CNNs, are the go-to solution.
What makes them so good at that?
They're really good at detecting patterns and features within visual data.
Uh-huh.
Kind of like how our own visual cortex works.
So they're like the pattern recognition experts.
Yeah, like master detectives.
Yeah.
They can pick out those subtle details.
Now, what about like the creative side of AI?
Right.
I've heard about ANNs that can generate art and music.
Yeah, you're thinking of generative adversarial networks, or GANs.
GANs?
Yeah.
That sounds pretty intense.
They're pretty cool. It's like two networks working together.
Okay.
One's called the generator and the other is the discriminator.
Okay.
And they're kind of in this competitive dance.
Okay.
So the generator tries to create realistic data, like an image or a piece of music.
Right.
And the discriminator is trying to tell the difference.
Between real and fake. So it's like an AI arms race,
Yeah, kind of like that.
pushing each other to get better.
And it works really well.
That's pretty wild.
Yeah.
What are some of the applications of GANs?
I mean, we're seeing some really amazing things, like realistic images,
Right.
music that sounds like it was composed by a human.
Wow.
And they can even generate synthetic data to train other AI models.
So it's like AI creating AI.
It's pretty mind-blowing.
It is mind-boggling to think that machines are now capable of being creative.
Right.
It really does blur the lines a little bit.
Definitely.
Now, I've talked a lot about the structure and types of ANNs.
Yeah.
But how are they actually being used in the real world?
Right.
Like, where are they making a difference?
Well, the applications are incredibly diverse,
Right.
and they're constantly expanding.
Uh-huh.
But one area where they're having a huge impact is in healthcare.
Okay.
They're being used to help doctors diagnose diseases,
Wow.
personalize treatment plans,
Wow.
and even develop new drugs.
So AI is actually helping save lives.
It really is. It's pretty amazing.
Are there other fields where it's having that kind of impact?
Absolutely. Finance is another big one.
Okay.
ANNs are revolutionizing things like fraud detection,
Okay.
risk assessment,
Right.
and algorithmic trading.
So they're making the financial world a little bit smarter.
Exactly. More efficient and secure.
What about areas beyond healthcare and finance? Are there any surprising applications that people might not expect?
Yeah, actually, ANNs are even being used in creative fields,
Okay.
like art, music, and literature.
Really?
Yeah, so we talked about GANs generating realistic images and music,
Right.
but they can also be used to write poetry,
Wow.
compose scripts, and even create video game environments.
So they're not just about like analyzing data and making predictions.
Yeah.
They can actually create new things.
Exactly. It's really blurring the lines between technology and creativity.
It's amazing to see how far this technology has come.
Yeah, it's really incredible.
Now, while all of this sounds incredibly promising, I'm sure there are challenges and limitations when it comes to ANNs.
Oh, absolutely.
What are some of the key considerations in this field?
Well, one of the biggest challenges is making sure that ANNs are trained on diverse and unbiased data.
Right.
Because if the data is skewed or biased,
Uh-huh.
the network will learn and perpetuate those biases.
That makes sense.
And that could lead to some unfair or discriminatory outcomes.
Yeah. So it's important to be mindful of the data that's being used to train these networks.
Absolutely. It's crucial.
What are some other challenges?
Another challenge is the interpretability of ANNs.
Okay.
You know, they can be really complex and opaque.
Yeah.
So it can be difficult to understand how they're actually arriving at their decisions.
Kind of a black box.
Yeah, kind of. And that can be a concern, especially in areas like healthcare or finance.
Where the decisions have real-world
Well,
consequences.
where those decisions have a big impact.
So there's a need for more transparency.
Definitely. We need to be able to understand how these systems are working.
And what about the resources required to train these networks?
Yeah, that's another challenge.
Like, are they very computationally expensive?
Some of them can be, especially the really advanced networks.
Right.
They require a lot of data and processing power,
Uh-huh.
which can be expensive.
So it's not like something that everyone can just set up in their basement.
Not quite yet, but researchers are working on making them more accessible
Okay.
and more efficient.
It sounds like there's a lot of research and development still going on in this field.
It is. It's a very active area of research.
This has been a really insightful conversation.
I've enjoyed it.
I feel like I've learned a lot about artificial neural networks.
Me too.
And I think it's clear that they have the potential to revolutionize so many different aspects of our lives,
Absolutely.
from healthcare to finance to even the creative arts.
It's amazing to think about all the possibilities.
So as we kind of wrap up this deep dive into this fascinating field,
Yeah.
what are your final thoughts?
I think ANNs are one of the most transformative technologies of our time.
Mm-hmm.
They're changing industries,
Right.
driving innovation,
Yeah.
and reshaping the way we live and work.
It's exciting and a little bit scary at the same time.
I agree. It's a powerful technology that we need to use responsibly.
And as we continue to explore the world of ANNs,
Yeah.
it will be fascinating to see what new possibilities and challenges emerge.
Absolutely.
And of course, a big thank you to Jörg-Owe,
Yes.
whose essay really guided our discussion today.
It was a great starting point for our deep dive.
Yeah, so we'll leave our listeners with this thought. As ANNs continue to evolve, how will they shape the future of AI and our world?
That's a great question, one that I think we'll all be grappling with in the years to come.
So we talked about the potential of ANNs, all these really exciting applications, but Schneppat's essay also brings up some specific challenges
Right.
that we should consider when we're developing and deploying these networks.
Yeah, one challenge that he highlights is this idea of overfitting.
Overfitting?
Yeah, it's kind of like when a student just memorizes the textbook,
Okay.
but they can't really apply those concepts to new problems.
Right.
So in the context of ANNs, overfitting happens when the network kind of learns the training data a little bit too well.
Uh-huh.
And it becomes overly specialized to that specific data set.
So it can't really generalize to new situations.
Exactly. It's like it becomes too rigid in its thinking.
And what are the implications of that?
Well, an overfitted network might perform really well on the data that it was trained on,
Right.
but then when it encounters new data, it might struggle.
So it can't adapt.
Yeah, it loses its flexibility.
So it seems like finding that right balance is crucial.
Definitely, you don't want it to be too specialized, but you also need it to learn effectively from that training data.
So are there ways to prevent overfitting?
Yeah, there are some techniques that can help, like regularization
Yeah.
and cross-validation.
And what do those do?
Well, they basically add some constraints during the training process,
All right.
and they help to test the network's performance on data that it hasn't seen before.
So it's kind of like adding those safeguards to make sure that it's learning in a more generalized way.
Exactly.
Schneppet also talks about this issue of vanishing gradients.
Right.
Now, I'm not familiar with that term. Can you explain what that is?
Sure. So imagine you have a signal traveling through a long chain of components,
Okay.
and with each step, that signal gets weaker and weaker.
Okay.
That's kind of what happens in a deep neural network with many layers.
Uh-huh.
The gradients, which are essential for updating the weights during the learning process,
Right.
they can become really small as they propagate back through those layers.
So it's like the learning signal is getting lost along the way.
Exactly. And that can make it hard to train those deeper layers effectively.
So how do you overcome that?
Well, there are a few different techniques researchers have developed, like
Uh-huh.
using different activation functions
Right.
or employing specific network architectures
That makes sense.
that are designed to help with the flow of gradients.
So it sounds like while there are challenges, there are also solutions being developed.
Absolutely. It's an ongoing area of research.
Well, this has been a really fascinating deep dive into the world of artificial neural networks.
It has.
And I think we've learned that they have the potential to revolutionize so many different areas.
Yeah. From healthcare to finance to the creative arts.
It's really mind-blowing to think about all the possibilities.
And Schneppat's essay was a great guide for us in this exploration.
Absolutely. A huge thank you to him for his insights.
And thanks to our listeners for joining us on this deep dive.
We hope you learned something new today, and we'll leave you with this thought. As artificial neural networks continue to evolve, how will they shape the future of AI and our world?